Hey there, it's Mrs. Hall. Alrighty, so today we are going to be learning about direct and inverse variations. It's section 4.3 and it's on page 169. Alright, so let's first look at the definition of direct variation. Direct variation is a specific type of relationship in which the dependent variable, aka the output, is a constant multiple of the independent variable, which is the input. So y, basically the formula for that is going to be y equals kx, where k is the constant of variation. Okay? And then we have an inverse variation, which is the same thing, just a little different. It's still a relationship, but it's where one quantity is a constant multiple of the reciprocal of another quantity. Reciprocal is what makes this one different. So instead of it being y equals k times x, it's going to become y equals k divided by x. Okay? This is used when you're given tables of values and they want you to find the constant. You can also use it when you're given certain scenarios. You can solve for what you're missing for. So let's first look at direct variation. Alrighty, so if they gave you a table, they're going to give you x and y values. Let's say they give you the points 0, 0, 1, 4, 2, 8, 6, 24, 7, 28. Technically, this can keep on going forever and ever. It's kind of like a line. It goes on forever in both directions. So, the directions for using this table, it says, find the constant of variation for this table of values. So, step 1, substitute one pair of x and y values from the chart into the general equation for direct variation. Alright, so first and foremost, the general equation for direct variation is y equals k times x. So now we're going to substitute one pair. I don't really like using zeros because if you end up having to divide by 0, you know how that's not really, it's undefined. If you want a definite answer, it's going to be easy to deal with. So let's go ahead and let's use the 0.14. Okay, so I'm going to sit here and I'm going to replace my y with a 4 because that's the y point that they gave me. So 4 equals k times, and the x value that I used from the chart is a 1. Alrighty, so step 2, we did step 1, we substituted the pair. Step 2 is going to be to solve for k. Step 2 is going to be to solve for k, so I'm going to rewrite this here. 4 is equal to k times 1. The opposite of multiplying by 1 is dividing both sides by 1. These ones here will cancel. 4 divided by 1 is just 4. So we know that k is equal to 4. Alright? K is equal to 4. And then step 3, which is our last and final step for this problem. Write the general equation for direct variation with 4 substituted for k. And we're substituting k with 4 because we know that k is 4, so we're substituting 4 for k. So now our equation is y equals k times x, but we know k is 4, so it now becomes y is equal to 4k. 4x. What am I doing? 4x. So this goes back to that table where we can theoretically find any point with this direct variation. I can say if x was 253, what would y be? Well, I can plug in 253 as x and figure out what y would be. And now on my chart, I can say 253, and I can figure out what y is based off of this formula. Alrighty? Now, sometimes they're going to give you certain information, and you're trying to solve for what they're asking you to. So let's look at a different example. It says, let x and y be directly related such that y equals 50 when x equals 5. Find y when x is 13. When x equals 13. Okay, so theoretically we should be able to create a table x, y. We have x is 5 when y is 50. So I can say 5 and 50. But when x is 13, they want to know what y is. Alright? So you have a good bit of steps to do here. Alright, so first and foremost, we know that we are using the direct variation formula, not the inverse, the direct, and the direct says y is equal to k times x. So this is the formula we will be using. Okay? So we've established that. We know that x is 5 and y is 50. When x is 13, what is y? So we already identified the known and unknown information. Now, let's substitute this point here to first find k. So step 1, substitute the given I'm going to say point. I'm going to say the given x and y values actually. So we know that y is equal to k times x, but we're saying that y is 50. We do not know what k is, but x is 5. So we're going to solve for k. To do that, we divide both sides by 5. These 5's cancel. 50 divided by 5 is 10. So now we know that k is equal to 10. This is important information, okay? Now, to find y, because our goal is to figure out what y would be, we know that y is equal to k times x, and we know k is 10, and we know x, for when they want you, for the y that you're solving for, x is going to be 13. So now we multiply, and 13 times 10 is 130, so that would be your value, 130. So the question says find y when x is 13. So to answer that question, your final answer, this is step 2 by the way, your final answer would be y is, or you can put equals, y equals 130 when x is 13. So you want to make sure you answer the question and tell them what y is when x is 13. Because y, if you say y is equal to 130, it could be when x is 2 and when x is 5. It's only when x is 13 in this case. Okay. Now let's go to inverse variation. So we also have x and y tables. Alrighty, so we want to find the constant of inverse variation for the table. So inverse variation, the general formula for that is y is equal to k over x. So we're going to again pick a point, same steps. We're going to pick -2, -3. I don't really like picking the first one, especially when it's 0, 0, so I always skip like second or third. The first one should work out regardless, but yes, so unless it's 0, 0, because anything can be multiplied by 0 or so yeah. Alrighty. Lost my train of thought, I apologize. So for step 1, substitute one pair of x and y values from the chart into the general equation. So we're saying that y is equal to -3. We do not know what k is, and x is -2, and we're going to solve for k. I'm going to multiply both sides by -2. These -2's will cancel, so I have +6 is equal to k. And now that I know k is equal to 6, you want to write the general equation for inverse variation with 6 substituted for k. So I'm going to put that y is equal to 6 over x. So you need this information to get you to your final answer. Alright, and let's look at another example. Let x and y be inversely related such that y equals 13 when x equals 25, and find y when x is equal to 5. So, in case the table helps you out, I'm going to draw that table again. And we have x and y. They tell us here that x is 25 when y is 13. And they want us to find y when x is 5. So we're looking to fill in this spot here. And we also know that it is inversely related. So since it's inversely related, we're going to do the formula for inverse variation. Not the direct, the inverse. So y is equal to k over x. We're going to first solve for k, so I'm going to plug in my x and y values here. So y is equal to 13. We do not know what k is, and x is 25. So you multiply both sides by 25. These 25s will cancel. And then on your calculator, on your phone, you can do 25 times 13. And you'll get 325, which is equal to k. This is an important bit of information. Now you have to find y when x is 5. So we do not know what y is, but we know k is 325, and we know x is 5. So y is 325 divided by 5. So on your calculators, go ahead and do that, and you'll get y is equal to 65. Alrighty. With that being said, that should everything you need to know. Your assignment today will be page 173, numbers 1 through 6, and numbers 9 through 14. Just a heads up on the word problems. It'll give you, like, for number 5, it tells you C and D. It doesn't matter if you do C and D on the table. Sorry. Don't know how that happened. Okay. It doesn't matter if you do C and D like that, or if you do D on top and C on the bottom, as long as you're, whatever it gives you. So for number 5, for example, let C and D be directly related such that D equals 16 when C equals 4. So find C when D is 28. So as long as you match it up, so 16 and 28 have to match with the letter D, whereas 4 and what you're solving for has to match with C. So either or would work. Just make sure you keep these together and then keep these together.